to this morning's debate on smart factory, big data and AI. The software situation for M2M software and supply chain software has been developing at quite a rapid clip. You can see that just by looking around the factory floor here with the CFX system. We're here to debate the software situation, supply chain situation, and also the security of these systems. And I'm joined by a very distinguished panel. On my left-hand side, we have the chairman of the CFX standard, Jason Spira. Nice to see you, Jason. Of course, you work for Aegis as well. To his right, we have Jay Garaji from Siemens Mentor, I believe is the correct name of the company now.
Yes, it is. Thank you.
Yeah. To my right, Marcus Wilkins from ASUS, USA.
Pleased to meet you again.
Good to see you again. And of course, to his right, we have Francois Monet from Kyrgyzstan. Okay. Welcome, gentlemen, and thank you for joining us today. So my first question, and it's an obvious one to put to you, Jason, is: do you think that what's called the software wars, if you like, of machine-to-machine software, do you think it's starting to settle down now with the CFX?
Well, I'm speaking with my IPC hat on, and I tend to think so. I mean, when one looks around, right outside this booth, we can see in the 23 vendors that have the CFX tape around their booths. Those booths are emitting real-time CFX using the free toolkit on their machines. As of 3 p.m. last night, there were over 31,000 page views to the demonstration site, right. And over 800,000 messages without error transmitted through the cloud down to people's cell phones. So I would say that the practicality and the real nature of the CFX data standard has certainly been resolved and proven.
Right, that's incredible. And of course, this is just a test to show proof of concept, really. The actual standard itself is not going to come out till later in the year.
It's a bit more than that, because the IPC SDK, the development toolkit, the software module that enables CFX to emit natively from a machine that's free to the industry, is now actually resident on 43 different machines on the floor. Mm-hmm. And because of the success of this demo, the requests to implement it on other machines has been quite a deluge during the show. So it's more than a demo. Those messages are the CFX messages, and implementing further messages, which some vendors have done, is underway. Mm-hmm. So this is actually practically applicable in the field.
Right, okay. Now, Jay, you have obviously got the OML system as well, but it integrates, I believe, or it cooperates with CFX and other systems. There's a lot of other vendors, like Panasonic, ASM, etc., Yamaha. They have their own solutions too, but they cooperate or sit on top of CFX. So what is your view on the current status?
Yeah, and I think you've kind of said it correctly. CFX as a standard is a standard when it's released. As with all standards, we want to be an active participant in the industry. We will adhere to it. We'll be reading it. Trust me, it'll make our life easier as well when more and more vendors are out there producing it. Yeah. I think as newer and newer machines come out and they do have CFX, whether vendors decide to charge for it or not, that's a separate topic. But at least with its availability, we can see, a positive influence and the opportunity for us to collect that easily. Right. We have the opportunity to go back in time for older machines with our hardware and then translate it to CFX and then make that available as well through the OML interface. But I think the key thing here is it's a good thing for the industry. It needs to be
benchmark.
To some degree, yeah. Whenever it's released, I think as more and more vendors come online, it'll just make our life easier. Right. Just a small note on that, we also have to keep a little bit of an eye on the ball in the sense that assembly manufacturing is one cog in a wheel. Mm-hmm. That board needs to go and sit into a box. And that box happens to be manufactured in a completely different process, and they have their own things going on. So hopefully this is just step one, and then we can start being a bigger part of an ecosystem, and with a lot of the mechanical PLCs and interfaces to that, trying to bring everything together would probably be more ideal in the future.
No, that's absolutely true. And in fact, David Bergman alluded to that yesterday when he was saying that at the PCB end, at the bare board end, there doesn't seem to be, much of a plug-in or a solution at the moment. So there are other areas there. Marcus, if I can turn to you, you had some experience with, or were involved with the Hermes standard, which comes in at the lower end, putting packets of information from machine to machine and controlling the belt speed. This integrates also with CFX. What is your view on it?
So coming from the equipment side, obviously we have a different point of view. I mean, number one, there is more than just the SMD line. There's final assembly, there's what we call material logistics within a facility. And I think some of these standards that are coming out these days, maybe Hermes, CFX, or Jara, or Adamos, whatever they might be called, they have to develop and adapt as well. And I'm sure that's the normal way how it's going to progress.
Right.
But we also see the necessity to walk away from a two-signal standard that has been around for I don't know how many thousand years by now. So I think the participation is required, is necessary. We are definitely a strong supporter of these various standards, because standards mean that our customers are not relying on a single source anymore. If that single source goes away one day, I might be stuck in a corner. But also we see the necessity because today we find ourselves in a situation where we have to develop and customize MES solutions for all the different global key accounts. So they all have an awesome solution, but it's their own, and we have to adapt to that. So Hermes, we believe it's going to be more a machine-to-machine communication situation that is going to help us to improve traceability. We believe CFX is going to do quite a bit of data logging, traceability up to a higher hierarchy MES system or database. And then there's other systems, for example, Pulse, that is the machine to the user, that is also open to anybody who wants to participate. But these all have their individual place in the entire mix of standards that will help us to live up to the Industry 4.0 expectation one day.
Yeah, absolutely. So, Francois, do you think, does it make your job any easier?
Totally, I agree with all the comments that have been made so far, that industry standards are a very positive thing for the industry. There's already a lot of standards that exist. There are new ones coming up, and it's all very positive, again, because it will help different systems interact more easily, which is what Industry 4.0 is all about. I mean, the machine-to-machine is important, but I think it's just a small part of the bigger scheme of things. As the machines and the software, come together, it's more than just one layer of software. You have the connectivity is definitely important, but you have the the MES layer, which we're all very familiar with. But there's also many other layers of software that are really key in a smart factory, starting from all the way from the ERP to the PLM, down to planning and scheduling, down to MES, down to the machine software. There's many different layers, and depending again as we speak, if it's SMT or if it's final assembly, then different standards come into play and different layers have to interact. So it's a pretty complex puzzle. But I think that's why there are several vendors, several machine vendors, several software vendors that are actually actively involved in all of these efforts, for the benefit of the customers in the end. But the customers will drive all these initiatives. If a standard is developed but no customer is asking for it, obviously, the machine vendors will not necessarily take the effort to support it, and the same for the software vendors.
Right. So. Right. I think one thing, and it's going to save you all, and that is time doing programming and making up pieces of software and patches for customers time and time again, doing the same thing. So at least the standard creates a benchmark for people to work to. Jason, what about security? It's a big issue. It's a big issue in every industry at the moment, but I believe you're using a fairly secure system for this.
Yes, there's many aspects to security, and this is kind of a topic of confusion that I think in the industry needs to be discussed. Is when you're talking about a data protocol, which CFX is, the messaging and so forth, there's the security of the data over the wire. Are you encrypting the packets that are flying across the wire? The answer with CFX is you can. You don't have to activate that, but the broker chosen is used by most of the banking transactions in the world, so clearly it supports the 128-bit encryption and so forth. But those implementing it do not have to turn that on. But one has to think, though, if you're within the enterprise only, the encryption, the security is really handled by the enterprise IT infrastructure, But if you, like in the application we see on the show floor today, it's flying out of this show floor through Wi-Fi, then up into the internet and back down through the cell phone network. In that case, you might actually want end-to-end encryption, which CFX does support.
Right, okay, yeah. I had looked at a number of other industries are looking at sort of blockchain style encryptions to try and make things a bit more secure, but if you're already using the banking system, then there's no need for that, I'm guessing.
Well, the blockchain is what the analysts, speaking to some of the analysts, they say is very early in the hype curve. You know, everybody now thinks blockchain is going to do everything for everybody, and this is a natural cycle. Blockchain, I believe, is a very exciting technology for certain applications, but in others perhaps not. So like for example in the supply chain, counterfeiting, parts, because blockchain to work requires that there are a lot of willing participants, lots of end nodes with relatively small, possibly high frequency transactions. That's basically the definition of component supply. And I think that's an ideal application. If you're moving around massive traceability data and you only have a few endpoints that are even interested in the product traceability for that unit, blockchain may not be the best application. So it really is an application-specific thing.
Right.
So I would say that perhaps, but not always, is the answer to that.
Okay. Do you have any input on the security side of things, Jay?
Yeah, so I think I agree with Jason in the sense that the standard itself is a standard. And the implementation of security needs to be thought of as part of an implementation strategy, not as a reliance on the standard is or isn't secure. There's the standard, and then how you're going to implement that into your factory, into your software stack, into your implementation strategy of an IT or an OT infrastructure, I think it's critical.
Right.
It needs to be part of the conversation, but regardless of if the transport supports it or not, at the end of the day, the gateway into an organization is
critical.
Is absolutely critical, and designing those stages and the DMZ layers in order to ensure people can and cannot get in, and if they can, what are those things that are abstracted so that only, even through the encryption, and we know bankers get hacked all the time too, that's not the point. The point is when they do get what they get, is it useful? Is it just some unique IDs and a bunch of abstracted data that is just not meaningful to them?
Right.
And so there's different strategies on how to protect oneself. And I think at the implementation level is when it really needs to, where the rubber meets the road, and you have to make sure it's secure.
Yeah, absolutely right. I mean, Marcus, I think it's particularly important because once you're inside the factory or the enterprise walls, everybody's being encouraged to be open source and exchange information in a fairly open manner. So therefore the gateway into the enterprise has to be doubly secure.
Yeah, so in our world, we normally do not get confronted with security conversations because typically we are talking about a single facility. Now that is changing immediately when you talk about connecting facilities to one another with a global orientation on an MES system, for example. So I think in that regard, we as an equipment manufacturer, we still have maybe another year or two before we got to answer all these questions. But the other thing is also the security is a function of how much are you willing to invest and how much are you willing to work on it every day. So if you set up your own Wi-Fi, you have a choice. You can spend $100 or you can spend $10,000, and your security is going to be a function of that. I'm not sure that for every tool in a production line, blockchain, once it becomes available and is affordable, is the right means to secure that channel. Today for us, our first R&D projects with blockchain at ACES today are more geared towards pay-per-use, so totally different functions than just securing a connection between 2 points. So in our world at the moment, it doesn't seem to be a major concern yet, but that will change immediately when you talk about connecting certain facilities to each other outside of the individual facility. Absolutely.
Yeah. But Francois, I think that's coming though, isn't it? Part of the Industry 4.0 roadmap really is not just to connect everything inside the factory, but to connect with your suppliers outside of the factory, so that if you get a rush order coming in, you can look inside your supplier's facility to see what inventory he's got and how you can fulfill these orders.
Yes, absolutely. And I think this already exists to some extent, because obviously not all the factories are sharing, let's say, detailed machine data today. Most of the factories anyway don't, but they share a lot of information already about the product and the inventory and information like that. I mean, most of the transactions for buying components, for example, it's all in the cloud already, so to speak. It's already so I think it's just an extension of existing technologies that we have to consider, that maybe there'll be more data that will be shared, and whether that data will be more sensitive or not, I'm not sure. As Jay pointed out, if it's really just manufacturing information, this has no strategic value for most people, right? If you know the reflow profile of a certain product, it's not going to be a critical defense issue or a national issue. But again, every situation is different. Every company has to decide, what data they want to share between their factories, what stays in the factory, what needs to be shared, how and when, and that's obviously more of an high-level IT issue, I think, than let's say a machine-to-machine communication issue.
Right. Okay. So let me pose my next question to you, Francois. So I'll give you first chance at it. Let's look at the situation of introducing AI into the machine-to-machine software system. What systems do we have out there, and how reliable are they, and how safe are they?
AI is a very hot topic, obviously, in our industry and many other industries right now. It's a bit like Jason was saying about blockchain. It's a bit early in the hype cycle. A lot of people have very high expectations, but again, it's a technology like any other technology. So there are some applications where it makes sense, and but it's not a one solution to every problem. So the difficulty with artificial intelligence, it requires very deep domain expertise, as well as very deep data expertise. So you need data scientists come together with domain experts, to try to figure out exactly how to use AI in specific applications to create value for the end users. So I think the challenge will be to take those data scientists, the companies that make AI systems, because it's very specialized, and combine those with domain experts to try to understand, okay, where you can apply these technologies and how. So that's the challenge for the years to come.
Right. Okay. I think what I'm hearing, Marcus, is that AI needs to be introduced where you're using really large amounts of data, and as we increase the amount of data that we're actually able to pull off the line, then it becomes more of a more pertinent.
I would agree. However, keep in mind, just having data doesn't mean nothing. You have to be able to analyze it and do something with it and drive your conclusions out of this. So AI, I think machine to machine, we are still light years away from that. We are in an industry at the moment, we are still relying on a SMIMA signal. So now we are making this huge leap jump to the next thing. So AI, I think individually on certain tools with a lot of data, maybe in SPI, AOI, and so on and so forth, absolutely. If I look back at handling, material logistics, maybe it's coming. I mean, we're at the early brinks of that. If we monitor torque on a certain spindle and then we adjust parameters to survive maybe another 2 days, not go into overheating and this and that, I'm not sure if that is artificial intelligence, but this is going to be per tool on a need-to basis at the moment. I think before we get to a point where AI is going to be a contribution to more yield, higher yields in a production line, I'm not so sure if that's going to be around the corner. That is a tremendous development, and even today we are supposed to be an equipment manufacturer, and now we have more and more software guys walking around the hallways. So it's definitely changing our landscape as well.
All right. I mean, Jay, yes, Marcus is right. It's a big leap in technology, but one of the things that we're seeing over the last couple of years, there's so many new technologies opening up in our industry all at the same time that it's going to be here before you know it.
I would agree. And I think to some degree it is kind of here. We can talk about AI and its hype cycle, but a piece of AI is the whole concept of machine learning. And the machine learning algorithms today are already, at least in a lot of the academic research over the last 3 to 4 years, have proven that in certain aspects and hypotheses proposed in, let's say, for quality management and being able to automatically identify defects based on X amount of characteristics of the board and its related parameters of characteristics on the profile or process. This is being played with now, right? So I think it's going to come at us pretty soon, and it's going to come at us not only fast, but in a way that will ask us to really think about our current paradigms. Because our current paradigm is put a board through a machine, test it, defect collection, have somebody look at those defects, make sure that they're real, and collect it. Right. And now all of a sudden it could be, let's say in the near future, that because of the process characteristics and the design characteristics, a machine learning algorithm has gone through, and whatever this tester has gleaned out has already identified that these are false and these are true, and maybe already also identified what the right root cause should be and route it to the right place.
Right.
You know, working our way closer to that Industry 4.0 ideal state of it making decisions on its own. So I think it's not too far away. I think the algorithms are here. I think the infrastructure is here. We're putting the groundwork to ensure we collect the right data in whatever format we do. And now it's just putting the pieces of the puzzle together, I think.
Jason, do you agree? I mean, and how safe is it? I mean, you listen to, I don't know,
the Skynet question.
Yeah. The what's his name? Stephen Hawking or Elon Musk. They say it's man's biggest threat. What's your opinion?
Well, my opinion, remarkably, and it doesn't make for good press, is I agree with the panel overall that we are. It's a bit early, I think, for AI right now, but I would qualify that by saying that a normal thing in technology, and I think with people in general, is that when there are lots of technical building blocks on the way to a solution someone wants, it becomes daunting and we think it's far away. And AI can't happen if the mass of data and variables available to the AI is present. And these standards and the things we're doing are getting us to that point. So I agree with what Jay said, but perhaps for a different reason, is it could be closer than we think. Because when that data is suddenly available and democratized, then the AI engines can actually make use of it. So it might be on a nearer term horizon. Now to your question about risk, I'm not particularly concerned about the factories throwing out the employees, because the AI takes over or anything of that nature. But it is always a little concerning when autonomous decisions are being made. I mean, we're all concerned about the cars and what's going to happen, the risks with that. We are talking about non-parametric based decisions, not linear decisions that we're giving a machine control over the process. Now, the risk might be the loss of some recognized revenue or something like that, not death, but I think that's going to be a whole new frontier of risk and risk management that we've not had to deal with before.
But as you say, the standards that we're setting down just now are putting the building blocks in place for this when it eventually arrives.
I think so.
Yeah, okay. So, machine-to-machine software and these types of things are central to the argument, but another big part of the development inside the factory, of course, is materials management and how that works. We have an example that's been supplied by ACES here on materials management around the factory floor, where you're using a number of AGVs to deliver a variety of things, actually, not just reels, but other materials to the factory line. I think we can see a look at this now.
Yeah, so maybe if I just take a few words here. Some comments on the video we are seeing. So, typically we've been considered an equipment manufacturer, pretty proud of our in-the-line handshake between certain processes. So now we are changing that scope a little bit to go to the facility. So we are not only moving a product from A to B within the SMD line, but we also interconnected, let's say, components from a centralized storage location, in this case a dry tower, to maybe the lines, to the feeder setup station. Maybe the kitting has been done already. And I think we're definitely walking away from static conveyorized connections between various points, and we definitely make use of all the different technology that we have nowadays. And then in the end, it becomes an equation of cost of manufacturing. So AIV rollout is definitely going to be a little faster in some of the higher payroll standard countries. However, what is happening already in the Far East is absolutely scary or exciting, depending on what side of the fence you are. So I think we have to grow into connecting not only within the SMD line, but also from centralized storage, talk about different materials, maybe semi-finished product, you know, if I have a double-sided product, the first pass, for example, and then also materials into the facility and materials, finished goods out of the facility. And then I think we have to be very open to how do we communicate. There's other attempts from a lot of the automotive folks, material labels, so we can identify certain batches of products, different vendors for the exact same board, and so on and so forth. And that's just one teeny tiny example of, you know, a little culprit that we have to watch out for. So if you take that throughout the entire shop floor, that's a tremendous undertaking. And I personally would like to disagree with some of the other panels. AI on the shop floor is going to be a tremendous undertaking. If I look at how much time it will take to now deploy the standards, Hermes or CFX and all the others, and make them available to everybody, and that implies maybe I still need a link to integrate older equipment that I still have, I'm not going to throw away just because of a new standard. So how many resources am I willing to dedicate to that implementation? And then you're coming with AI at me. I think I have job safety for the next 10 years, I believe.
There's always going to be people with the legacy equipment on the floor and having to integrate the new systems, you know. But and alluding to your point on ID of components and things like that, it's another job for IPC really to get this labeling correct. So we have one label following the product all the way through its life, rather than, you know, a reel coming in with 6 or 7 different labels attached to it. But I think that's the way that's going to go. What do you see coming on the materials management side, Francois?
I agree with Marcus. There's still a tremendous amount of potential opportunities there for manufacturers to capture, because a lot of the cost of building product is to buy and manage the materials, whether it be components or otherwise. Typically, you know, for a printed circuit board assembly, up to 80% of the cost is actually the sum of the components. So one could argue that building boards is like a value-added distribution business almost. So how effective you are at managing these components, making sure you deliver the right components at the right time in the right place, and do that in real time is also very, very paramount. So, but you know, back to the topic of standards, you know, one example is that even today, after all these years, there's still no single format of barcode labels on those reels, right? Although there are several standards that have been actually released over the years, you know, some more industry specific, like the automotive ones, but even these companies that have huge purchasing power and a limited number of suppliers because they do super high volume, have a struggle to get their vendors to put the format of labels that they need, you know. So, but you know, people are pretty smart, and they came up with systems that can read suppliers' labels and extract the information. And if you have to reprint another label in a standard format, those are the things that need to be done if you want to get the value from the different systems. Yeah. You need somehow either standardize, you know, or find workarounds to normalize things, you know. So and that's I think one of the challenges that we still have and we will have for the years to come.
Yeah. Okay. All right. Well, guys, we're starting to run out of time, so I'm going to jump to my last question, really, and it's really an example of something I saw at Productronica in November. I was on a German equipment vendor's booth. They make reflow ovens and various other pieces of equipment, but they had an augmented reality system there where you could literally see inside the reflow oven in real time and see the profile, exactly where the temperature was, where it was peaking, etc. It was color coded too. They're also using this augmented system for virtual augmented system for training and for maintenance. You open the back of the machine and it tells you literally to go from point A to point B to change this, etc., this filter, etc. Is this a precursor to what we're going to be able to see eventually? Eventually, is the operator going to be able to walk down the line and literally see inside every machine?
My thought on the AR is that 2 years ago, it was almost like the AI thing. I think I was of the opinion that maybe it was a bit further down the line. I no longer believe that, because the applications, the oven one is great because it shows people what's possible, but honestly what our customers are telling us is there's actually much more, maybe not as exciting, but practical applications for AR to get rid of the real estate problem of PCs on the floor. All sorts of interesting ideas the customers are coming up with how could you apply Google Glass if it linked to an MES system. That more, like I said, not as exciting in a demo, but practical in the production process. I really think there's actually almost limitless amounts of things we can do with the AR glasses and when linked to a production control and documentation system.
Yeah. Okay, Jay?
Yeah, my thought on this is there's an area that's kind of ripe, and I agree with everyone here in the sense that we have to apply it in the right places. And an oven is a fantastic opportunity for us to see what's possible. When we're doing simulation, and as you know, the whole concept of a digital thread and a digital twin is running through the industry right now.
Yeah.
And that whole digital twin concept is ripe for AR because you can actually see what the production will look like.
Yeah.
You can actually visualize, if I do the following process steps, how will it affect? You know, and some of the simulation, factory simulation, automated simulation, robotic simulation software out there that do have some elements of AR today are able to identify those things to improve not only real estate but risks.
Okay.
You know, things running into each other, or things that are not placed right, or material that should be traveling from here to here, but because of all these other circumstances won't make it there because there's something in the way, to foresee those kinds of things. So production execution twinning, let's call it the digital twin of performance of production, is, I think, probably the next stepping stone that may be possible to see, and it would be a nice improvement.
So, Marcus, a practical tool, a useful addition?
Sure, I share one story. So I think having all the data, being able to read into the data, analyze it, I think is one thing. But then we as human beings, we have to trust it. And if you ever tried to hop in one of those autonomous vehicles and take your hands off the steering wheel in the parking lot, that's one thing. Do that on the highway, it's a totally different story. So I think we as human beings, we still have to learn to deal with all of that. Good example in the SMD world is an AOI. We have a ton of data, we have angular cameras and this and that, and then we place an operator somewhere to look at the error images. You know, the system said this is a reject, so I don't trust it, so I have a human being saying, no, I look at it one more time. And then I've seen it lately also that then there's another vision system with just a CCD camera to give me a live image again. So I think it's a learning curve for us. It's an intriguing and exciting time, but I think augmented reality is coming. We are playing with that today. Do we need a standard to do so? I think it always starts with an idea, and then it's going to develop from there on. And some of the ideas will be scrapped because they don't make sense. Others take off because they do make sense for a lot of folks. And then it's gaining momentum, and it's going to develop into something really great.
Right. Okay. Yeah. The only thing I would say about your AOI example there is, of course, you know, we have the human intervention to say how much we trust the machine. But there you go. Francois, last word to you.
Well, your example is very interesting. I think Industry 4.0 has brought up a lot of discussions in the industry, and a lot of hype and a lot of expectations, and that's our responsibility as a software vendor is to make sure that these expectations are realistic. You know, people get carried away with after they've seen demos and of these technologies, and they want to see that in their factories, but it doesn't always make sense. You know, it makes business sense. I mean, it's not about having the latest and greatest technology. Is actually getting some business benefit out of it, and really most people are so far away from these types of technologies that we have to take them step by step and say, well, this is where you are today. You know, and here's the first step you should take, and then you'll get some business benefits from that. And then a second step, and then let's talk about augmented reality 5 years from now maybe. So I think it's being pragmatic and being realistic and setting expectations that actually people need and we can deliver is really important.
Right. Well, as I said, I think a lot of these technologies are creeping up on us a lot faster than we think. But this has been a wonderful look into the future with a panel of experts. I'd really like to thank them once again. Jason Spira from Aegis and CFX, Jay Garage from Siemens Mentor, Marcus Wilkins from Asus, and of course Francois Monette from Cogiscan. Thank you, gentlemen, and thank you for joining us.